Hello. Okay, so measuring intelligence. As you saw from trying to make your own definitions of what intelligence is, you notice that not only is it hard for us to come up with a definition that we all agree upon, but also it like finding a way to measure that definition is going to be quite difficult because you're trying to measure a construct, something that doesn't physically exist. Its existence is dependent upon how it's defined. So some of the first people that studied how to measure intelligence were um, Alfred Binet and Theodore Simon. And they weren't actually looking to label anybody. They fed into a really nasty movement. They were part of this larger eugenics movement, but that wasn't really their intention. That's basically how their work was misused. Ultimately, what they were trying to do is figure out a concept called mental age. And a mental age is what a person of a particular age should know. So, like, if you are 10, what is it that 10-year-olds should know? And then your intelligence is going to be based off of that. So, do you know less than what an average 10-year-old would know, or do you know more than what an average 10-year-old would know, or do you know what an average 10-year-old would know? What they were actually trying to do was figure out a way to help kids in school. So they were trying to study students who did well in school and students who didn't, and see if they could come up with a series of tests that would be able to predict school performance. So what they wanted to do was essentially see the way people that performed well in school differed from the way that people didn't, so that they can predict students who wouldn't do well in school, so that they can put something in place to help them. They weren't really looking at nature and nurture sides of it. They were looking, so they weren't considering essentially like what you were born with. They were considering essentially that what do we need to put in the environment to help you close the gap. Now, somebody named Piaget, Jean Piaget, also worked with them, and he's going to get sidetracked in a different, very interesting way. But when we talk about Piaget, I'll remind you that he was working with these two. And so these guys, and they were based in Paris, they came up with a series of test questions where they could make a prediction on how future school performance would be. They can make this prediction. And then they were going to implement strategies to help students close the gap. And what they recommended is something that's actually not used anymore. They recommended, and I would write this down if I were you, they recommended mental orthopedics, which is similar to saying drilling a concept, right? So repeating something so that you don't have to think about it, so that you can recall it without effort. Schools have moved a long way from this idea of drilling, is what we would call it now. More, they want to engage students with the material, motivate you more, have you think about stuff, move stuff around. But there is something to be said about having a basic fund of knowledge in which to work. Now, when they found which students would do well in school, they labeled these students bright. And when you're calling someone bright, this is where it's coming from, right? Binet and Simon. So they label the students who were performing well, they label them bright. And keeping the same kind of language in mind, when students didn't perform well, they were labeling them dull. So they were trying to find differences between the dull and bright students. As bad as that may sound, they were not actually trying to label students. They were trying to help them. The fact that intelligence testing fed into this larger eugenics movement was really nowhere near what they were trying to do. But I should mention that this idea of eugenics, of selective breeding, unfortunately, the intelligence testing movement is going to feed into that. This was in the early 1900s. People were searching for this superior thing, and I mean, obviously Hitler is going to be part of this, but there was a lot of parts to this. So the intelligence testing movement was pretty nasty, though the intention behind this particular test was not. Ultimately, in some places, including some places here in the United States, people are going to use intelligence testing results to indicate whether or not you can go into the military, or indicate whether or not, depending on where you were living, whether or not you should be allowed to procreate. you could see where this would go really bad really fast, and it did. Now, the Stanford-Binet is another test that was created to measure intelligence. It was built off of Simon and Binet's work. Stanford is not a person, Binet is a person. So Louis Terman was working out of Stanford University when he came up with the Stanford-Binet test. Essentially what he was doing is recognizing the fact that Simon and Binet, when they wrote their test, they wrote it for people in Paris. Terman was like, okay, well, here I am working in Stanford. I want a test that applies to students in California. And he recognized that he had to make changes to make that happen, not least of which was language. And here we're going to see the beginnings of really what is the modern day Stanford-Binet. This test was used to test children ages 3 to 16. So at this point in time, when we were considering measuring intelligence, we were looking at mental age versus chronological age. So your chronological age is a child's actual age, right? So if you're 16, that's your 16 years old, that's your chronological age. Your mental age is, like you could be 16 and have a mental age of 14. You could be 16 and have a mental age of 18. At this point, you can recognize that there are certain things we just expect like a kid at age 3 to know and not know, and that's true at age 6 or 12, what have you. But this cannot possibly continue on indefinitely, because how much do you think a 40-year-old should know over a 60-year-old, or not over, but as compared to a 60-year-old? So these tests were really obviously meant for kids. Nowadays, if you wanted to get an IQ test done, they have tests for adults as well. A person by the name of William Stern came up with a formula for measuring IQ. Again, you're going to see the limitations of this, but at the younger ages, it works out okay. It's still going to remain the basis for the type of numbers we assign to IQ scores anyway. But essentially, he said that you have, a mental age. If you put that over top of the chronological age and times it by 100, you have a person's IQ, or intelligence quotient. So if we look at the first problem, an 8-year-old has a mental age of 10. What is her IQ? So we know that mental age goes on top, right? So I would write that 10 divided by her chronological age, which would be 8, times it by 100. Now, just in multiple choice, you can rule out some answers really quickly, because you should know by looking at this that the IQ will be over 100, right? If the mental age is larger than the chronological age, the answer will come out over 100. And then if we do the math on this one, we will end up with an IQ of 125, which would be a z-score of over +1. If we take the second problem, a 12-year-old, so I put the 12 in the denominator, has a mental age of 9. What is his IQ? So I'm going to times that by 100, right? And I can already tell by looking at it that this 12-year-old, will have an IQ of less than 100. And when you work out the math, it'll come out to an IQ of 75. I would try these out and make sure you know how to do them. And lastly here, we have a boy who has the mental age of 10 and an IQ of 200. How old is he? Well, okay, you just have to solve that algebraically, solve for x like you would, in any problem. So we know the boy's mental age, not his chronological age. So that mental age goes on top, right? So 10. I'm solving for his chronological age. I'm still going to times it by 100. And I know that the answer will be 200. He has a untestably high. We would call that an untestably high IQ. IQ scores are not, or IQ tests are not meant to test people that high, or that low for that matter. It's meant to test averages. So once you get past the second standard deviation, a person's score will alter quite a bit with one or two changed answers. but we will know here, once you solve it algebraically, that the child is 5 years old. Factor analysis, this is something that was developed by Charles Spearman. He used FA, or factor analysis, to discover his G, or general intelligence. This is a statistical procedure that identifies clusters of related items on a test. Now, if you remember, I was saying that there were certain subtests, like ones involved with language stuff, vocabulary, or math items, like anything dealing with fractions and percents, that give us a pretty good indication of how a person would test in other areas. That's what Spearman was trying to determine, which is how he ended up drawing the conclusions that he did about G, a general intelligence that affects all areas. But essentially, you use factor analysis. We're not going to do it. It's a statistical procedure. We're not going to do it, but just know what it is. Use it to identify factors that explain a variety of results on different tests. So in an intelligence test, if you get a high score on a test of verbal ability, we also know that you will test well on other areas that require verbal abilities, or that you will likely test well in those areas. The most widely used intelligence tests, and people are backing away from using intelligence tests as frequently now. Obviously, it has a nasty history, right, feeding into the eugenics movement. You're looking at a battery of tests. You want to consider, if you're diagnosing somebody with something, you want to consider a range of things, not just intelligence. And the multiple intelligence people would say that, intelligence is a lot of things, not just this. So let's pull away from this standardized testing stuff. But in terms of the tests that are used, and there are many different types of intelligence tests, and they're targeted for different ages. But some of the most commonly used ones here would be the ones developed by David Wexler. On his tests, he does give an overall IQ score, but also breaks down your score into verbal and performance scores. The good news about these tests, as I mentioned, was a problem earlier on in the testing movement, was that you didn't need to actually speak English. You don't need to actually speak English to take these tests. Earlier on, you spoke a different language than the one that you're here in the United States. The expectation, I know this is horrible. The expectation was that you were to speak English. There was not much flexibility on that thinking back in the early 1900s, and so you were deemed as feeble-minded or unintelligent if you couldn't take a test or couldn't do well on a test, and they would disregard the fact that maybe you speak Spanish and the test is in English. But Wexler developed a series of subtests so you could administer this IQ test without having to speak the same language. Obviously, the ideal situation is you test a person in their native language. And these are the names of the tests. And what I want you to see really here is not that I expect you to know every name of a test, but that you would recognize it if it showed up in multiple choice. What I want you to notice here, and we call these the WACE, the WISC, and the WIPSI, is that they are targeted towards different age groups, right? So the WACE is for adults, the WISC are for school-aged children, and the WIPSI would be for preschool children. And a point on the types of tests that you can take here. When we are dealing with intelligence tests, we're really talking about aptitude tests. So an aptitude test is a test designed to predict your future performance or your actual capacity to learn something. It's intended to predict your ability to learn a new skill. So when we look at the SATs and the PSATs, we're looking at tests that are meant to predict, actually, the SATs quite specifically are meant to predict success in freshman year of college. You'd think it would predict more than that, but really it doesn't. You'll also note that if you're testing capacity, and someone takes a test, are they going to get their highest possible score? Well, really, it depends how hard they've worked, their study skills, what they've been exposed to, their environment, health, socioeconomic status, that sort of thing. which is why SAT tutors are able to say, oh, I'll help raise your score by X number of points. They can't actually change your capacity to learn, but the assumption they're making is you haven't done everything you can to meet your full potential. Achievement tests, on the other hand, are tests that are designed to test or assess what a person already knows or what a person has already learned. When you take the AP Psychology exam at the end of this year, that will be an example of a standardized achievement test. And the question, are IQ tests culturally biased? Well, they shouldn't be. So let's start out by saying that remember the bell curve, right? So we're looking at average IQ is 100 with the standard deviation of 15, right? So technically then 68% of the population should have an IQ between 85 and 115. 95% of the population would have an IQ between 70 and 130. Because things in life tend to be normally distributed, when access has been the same, when everything else is equal, everything should fall out pretty normally distributed. If everything were working as it should, technically, then anybody of any race or any ethnicity, when tested on their IQ, would be represented all over the map. There should be no distinction between gender, ethnicity, race. There should be no distinction at all. But that's not the way it works out. And so we know that the tests are culturally biased. And I think there's a lot of things. It's the test itself is one aspect. I remember one year on an SAT, I was proctoring an SAT years ago, and there was a question that you had to know what sushi was in the question, and that's culturally biased. In certain areas of this country, you would find people who have never had sushi before. But when they test, you'll find that what you're actually seeing are opportunities, like different opportunities for people. So when you look at these tests, yeah, they are biased. And you see that Asians tend to perform higher on these things, followed by white people of European descent, followed by black people, followed by Hispanic people, and lastly, indigenous people, Native Americans. But remember, what I said is still true. Intelligence is normally distributed. What's not normally distributed are opportunities. And until that changes, we're going to continue to see bias in tests. Now, I'm not promoting IQ tests in that way, but I'm just saying that, until we make everything else fair, we're going to continue to see those types of differences. But if we're actually measuring a person's capacity, all else equal, you would not see any distinction between gender, race, and ethnicity in a test. And lack of exposure is going to lower IQ scores, right? So if you are, if you don't have a home, or you have to help pay for your, family's bills, so you have to work hard after school, you're worried about safety issues. So even when you're in school, let's say you can't attend to it, or you're hungry, you don't have enough to eat. These things are going to affect your ability to do well on an IQ test because you're not getting what you need. So you're not going to, just by your environment alone, you're not getting what you need in order to do well on a test like that. Other things, more important things have come up. So socioeconomic differences, they probably play the greatest role of all. Socioeconomic people on the lower end of the socioeconomic spectrum don't perform as well because there are so many other things that need to be in place for them to do their best in a learning environment. There's a substantial genetic component, so the capacity, you're starting kind of with what you're starting with. Now it's about meeting that capacity, so it's a nature-nurture play. And obviously motivational factors. So some people might have the capacity to do really well, but not the motivation or the interest. Not understanding the language well in the environment that you're in, that will affect how you score as well. But members of every ethnic group, every race and gender are at all levels of the curve. And when the test is really working, that should be completely integrated. And I think I said most of this, but factors that affect your IQ, obviously your genetics. So you're going to see genetics, in terms of genetics, your IQ scores are going to be in and around one or both of your parents' scores, some maybe a little higher, a little lower, somewhere in between. almost precisely the same sometimes. But remember that at the next point, environment also plays a role. So like, are you safe? Are you being fed? Do you have access to good information and access to things you need to learn? Early intervention helps. So finding kids who are, don't have the language skills that they're supposed to have, or whatever the skills are that they're supposed to have at a younger age, identifying that early and getting on that early, trying to get that in optimal periods. Schooling is another thing. So where you go to school, what kind of access you have to, good literature, good teaching, that sort of thing, will affect your score. Not your ability, but your score. So a few factors that affect your IQ. Just it's interesting to look at it this way. So IQ is associated with simple abilities. So you take a very simple type of test, an IQ under 70, which I'll explain what that means, but you're looking at a z-score of -2, right? It would take somebody at that place 5 times longer than the average person to solve a simple task. School attendance also correlates with IQ. You need to be present in school in order to learn what you need to learn. But IQ is not influenced by birth order. So I think there's a thought that like, oh, the firstborn was more intelligent, or no, not at all. So not by birth order, but here's some of the things that we've noticed, and this is all correlational stuff, not causal stuff, right? But you'll see that people that tend to test higher tend to start to have families later, and the families tend to be smaller. Now, obviously, there are exceptions to that. I would like to point out, like as intelligent as I know my parents to be, they had 7 of us. There were 7 kids in the family. So just because one of these things, you're like, oh no, I'm not going to do as well, because no, it's just a correlation. I'm sure you have everything else in place that you need, and it's not something to worry about, just something we've noticed in terms of the correlations. Potential trends, not causality. But people that don't stay in school, maybe drop out of high school, they often will start families earlier, which gives them more time to have really bigger families. That doesn't mean that they don't have the capacity to learn better, but for whatever reason, they're not getting everything they need. And again, don't let any of this upset you, because it's all correlational, but children who are breastfed tend to have a few points higher on their IQ. Correlational, though, that's all. People with birthdays at the end of the year tend to have lower IQs. Like, not hitting on everything here, because, like, man, I have a birthday at the end of the year. But it's really just because that kids with birthdays at the end of the year often are the youngest kids in their class, which means that when they're being exposed to new information, they may or may not be ready for it. Which is also why it's correlational, because some kids are just ready at a younger age and some kids are not. So again, don't let any of these things bother you. Correlational stuff only, and it's some observations that people have made, but they don't determine anything. So intelligence is considered plural, not singular. IQ is correlated with head size, but like barely. Honestly, very, very small correlation. If you look, it's not about like one person having a bigger head than another person, so therefore they're smarter. It's not like that. And again, remember that this is correlational. It's compared to other mammals, other animals. The size of your brain, the size of your head compared to your body size. That's the proportion that you're looking at. But intelligence scores also predict real-world outcomes. So even with similar levels of schooling, people who would test higher on the intelligence scale also seem to have higher pay. Once again, correlational. Okay, so intelligence also depends on the context. You could be very intelligent in one context and not in another. I think that would make sense. There's also this observable pattern of IQ scores going up. This is called the Flynn effect. That will come up, so make sure you know what the Flynn effect is. But there are a number of things that contribute to that, not because people themselves are being born with, like, say, a greater capacity to learn, but there's better nutrition, more schooling, you have better educated parents. These are some of the contributing factors. Honestly, the changing literacy rates, or the changes in literacy rates, are probably the biggest thing affecting that. And IQ scores are influenced by the cafeteria menu. So when Michelle Obama had that whole initiative to make cafeteria food healthier, removing preservatives, dyes, colorings, artificial flavors. It can cause a substantial increase. I say cause, I probably shouldn't. It correlates to an increase in IQ scores. And obviously, the biggest gains are from the people that were originally testing on the lower end. Now, when we construct intelligence tests, there are three things that we have to make sure. We have to make sure that the tests are standardized, which I will explain, that they are reliable, and that they are also valid. For standardization, the test must be pre-tested to a representative sample of people and must form a normal distribution or bell curve. You might find yourself part of a standardization process when you're taking, say, an SAT and you have an extra subtest that doesn't count towards your score. You'll see sometimes in some classes you'll have to take like a Regents test type thing that doesn't count as the Regents. Again, same type of thing. This is part of the standardization process. The people that need to be part of the standardization process need to be people that can be really randomly selected from the population, and they need to reflect the differences that you see in the population. Tests also must be reliable. So you can think of reliability as repeatability. So if I give you a test on one day and a test on another day, like your scores should be consistent. If I'm actually testing what you know, it should be repeatable. But I don't mean it like reliable in the sense that I think you would use it normally. Like if I were, if you just show up on time, or if I can count on you to get your work done or whatever, I might say, oh yeah, this is a reliable student, right? Now I'm talking about a number of different things. But here what I really mean is like, so if I were to take somebody, like say I have a babysitter that I hire, and the babysitter shows up 15 minutes late every morning. It's funny, the first word that might not come to mind is reliable on that one, right? But at the same time, that is predictable. It's predictable and it's consistent, so therefore that babysitter would be reliable, just not in the way we would typically use it. So for test, I want to know that I can give you that same test or a similar test and have the same or similar results. And quickly go through different types of reliability that you'll want to know. One is test-retest. So you compare a subject's scores on two different administrations of the same test. Obviously, you could run into issue of learning over time or familiarity with the test itself, but that would be one type of reliability. Split half reliability would be where you take a test and give half of it in one administration and half of it in the other, and or even like take the test itself, give one administration of the test, and divide the numbers in half and compare how a person did on half the test with how they did on the other half of the test. But notice, if I'm going to split something in half, I'm not going to have as many test items, right? So that could be a problem. So if I have 100 test items and I'm doing split half, now I'm really down to 50 to compare, right? But I'm never going to compare the first 50 problems with the second 50 problems. One, there's some fatigue that happens during a test. But two, tests that are constructed properly go from the simpler questions to more challenging questions as they go. So instead, if you're going to split something in half, you might compare how somebody does on the even numbers compared to the odd numbers. For inter-rater reliability, you're really looking for two people to grade a test. I would use this sort of thing on something where a test where there's more subjectivity. So if I have to grade, like, say, an essay, and I have a rubric, and the rubrics are usually pretty clear, but every once in a while you're like, that could go either way. It really depends on how you're looking at that. It's kind of on the line with something. And so in the case of that, you'd have somebody, one person grade it, another person grade it, and check to see if the scores are consistent. Regents grading, that's how that's done. So one person, like each essay is graded by two different people. You look for consistency in the scores. If the scores are not consistent, and we are following a rubric, right? But if the scores are not consistent, a third person would have to come in and grade that as well. Equivalent forms, a little challenging because you're using two different forms of a test in close succession, which means that you have to come up with a large number of items. Validity, on the other hand, is does a test measure what it purports to measure? So, you know what, if I am testing you on how well you'll do in an AP Psych class, and you take a test and you realize that I'm giving you like SAT type questions, it might not appear to have validity to you. That doesn't mean that it's not valid, but it may not appear to be measuring what it purports to measure. But obviously, if I like gave you a test and asked you all math questions and it's a psych class, there's no validity to that because I'm not measuring psych. That's what I'm supposed to be measuring. So one type of validity would be construct validity. You know what a construct, remember, a lens, something like intelligence, something that doesn't physically exist but depends upon how it is defined. Those tests would need construct validity. So they'd have to be well defined, and intelligence tests would go there. But when you're looking at mathematical reasoning or verbal reasoning, musical aptitude or ability, spatial ability, mechanical aptitude, motivation, these are all things that would be harder to, measure, so the constructs have to be well defined. With content validity, do the elements of the test relate to the content that you were taught, right? So you get a test on intelligence and memory, you should expect questions about intelligence and memory, right? For criterion validity, it's the accuracy with which a test scores can be used to predict another area of interest. So the degree to which content on a test or predictor correlates with performance on a relevant criterion. There are two types of criterion validity, which I will explain. So predictive validity and concurrent validity are both types of criterion validity. So predictive validity is how well performance on a test predicts future performance on some measure. So the SAT, you're trying to predict how well somebody will do in their freshman year of college, their first year of college. That's predictive validity. Concurrent validity is how well performance on a test predicts immediate performance on some valued measure. So if I am teaching a class on public speaking, and give you a test on this, the concurrent validity would indicate how well you would perform on public speaking if you had to do, if you had a public speaking assignment that day. And lastly, face validity. So does the test appear to measure what it purports to measure? So, and I think that, that can be an issue where, if I'm asking you about, I ask you some questions like, all right, do you want to test how angry you get? And I ask you about, do you watch violent TV shows? That seems to have good face validity, right? So, do you engage in, violent activities? Do you hit people? Do you, play violent video games? Are you in sports that have violent physical contact, or more aggressive, I should say, physical contact? These might all, seem valid, right? So if it seems valid to you, it has good face validity. But if I'm asking you also, do you wear socks when you go to sleep? I don't know if that has anything to do with, with anger and that sort of thing, or anger or propensity towards violence, but maybe it does. Maybe it's correlated. I have no idea. But the problem is that, let's say it is. Let's say that is correlated. You're taking a test and somebody asks you about your socks. You go what are you talking about? This doesn't make any sense, which could affect the results of a test. Ultimately, you need a test to be both valid, so measure what it purports to measure, and reliable, so repeatable. If a test is repeatable but not valid, it's useless. And finally, some factors that lower the validity of a test. If the directions are unclear, you don't know what you're supposed to do. Difficult reading vocabulary and sentence structure. So you're reading something, you're like, that didn't come out right, or what? Or words are too hard, that sort of thing. That could affect validity. Ambiguity in statements. Inadequate time limits. You don't have enough, just simply don't have enough time to get it done. An inappropriate level of difficulty. Poorly constructed test items that are inappropriate for the outcomes being measured. Tests that are too short. An improper arrangement of test items. You get test items at the beginning of a test that are really hard. Even if the test gets easier, you're going to blow somebody's confidence, and it will affect their ability to do well on the easier items. identifiable patterns of answers. So if you notice that the answers are like A, B, C, D, A, B, C, D, A, B, C, D, I know that would probably freak a lot of people out, and some people would just go with it. Teaching, was the stuff actually taught? And then the any issues surrounding administration and the scoring of tests can also lower validity.